Hello and welcome to today's video on halide ions. Just want to take a minute to say thank you for all the comments and all the feedback and all the subscriptions so far. It makes me feel like we're doing a really good job here and makes me feel awesome. So thank you very much. Like I said, today's lesson is on the halide ions. It's AQA specification 2.3, group 7, the halogens. It's just carrying on from what we looked at yesterday on the halogens. So halogens gain an electrons to form an ion, which we call a halide. They are reduced. So remember, reduction is gain. And we take our example here of fluorine and we add an electron to it. And remember to stick some brackets around the outside of it to give it a negative charge. So we can see the electron configurations changing there. So we're adding one extra electron into the 2p orbital. And this is shown here by the equation of half F2 plus one electron makes F minus. So when we consider the reducing power of the halides, it's very similar to how we look at ionization energies, really. So for it to be reducing power, it needs to be able to lose the electron that it's just gained. And if we look across fluorine, chlorine and bromine, as they get bigger, it is easier for them to lose that electron that they've picked up. So the bigger the ion, the easier it is, the better they are at being reducing agents. So we look at sulfuric acid reacting with the halides, and we look down fluoride, chloride, bromide and iodide. We can split them into two groups, one with the fluoride and the chloride. Now these are not particularly good reducing agents and they react with the sulfuric acid as an acid. Bromide and iodide, these are quite good reducing agents, and these react with the sulfuric acid as a reducing agent, so they reduce the sulfuric acid. If we look at sulfuric acid then in more detail reacting with the fluoride and the chloride, we can see that these equations here show them reacting it with an acid. We've got the sodium fluorides and the sodium chlorides as a source of the halide ions. They both produce sodium hydrogen sulfate, and then they produce the hydrogen halide at the end. Our first of the more complicated examples is sulfuric acid reacting with sodium bromide. We're going to split this into steps. So in step 1, we have the sodium bromide reacting with the sulfuric acid to make sodium hydrogen sulfate and hydrogen bromide. Now in this case, the hydrogen bromide goes on to further reduce more sulfuric acid, forming bromine, sulfur dioxide and water. We can look at this as an overall reaction here, and we need to be able to remember the overall reaction to think of the sodium bromide as a reducing agent, the sulfuric acid as the oxidizing agent, and we've got some observations of the bromine being an orange gas and the sulfur dioxide being with choking fumes. These are key observations that will be required on an exam question answer. When sodium iodide reacts with sulfuric acid, it first forms hydrogen iodide. This then goes on to reduce sulfuric acid further. And there are 3 possible products depending on how far the reduction of sulfur goes. You need to know all 3 to answer questions on the final exam. The first is SO2, and sulfur has gained 2 electrons and now has an oxidation state of +4. The second is sulfur, where it's now gained 4 further electrons and now has an oxidation state of 0. And the final one is hydrogen sulfide, where it has gained 2 more electrons and now has an oxidation state of -2. It is possible to summarise the whole process with the full reduction of sulfur in this equation. Past exam questions have used this equation, as well as requiring you to write out the equations to form any of the 3 sulfur products from the previous slide from sulfuric acid. It's also important to be able to identify the reducing agents and the oxidizing agent. We need to also know the observations from these reactions. Sulfur dioxide causes choking fumes, sulfur is a yellow solid, and hydrogen sulfide leaves a bad egg smell. We also need to look at the iodine. So solid iodine is grey, and iodine gas is purple fumes. The reason why we talk about iodine gas is because the reaction is highly exothermic and the iodine often sublimes to form purple fumes. So halides form colourless solutions, and we have a method for testing which halide is present, and we call that the Silver Nitrate Test. To carry out the Silver Nitrate Test, we react silver nitrate with the halide solution to form a precipitate. As shown here, the halide is represented as X minus in the equation, and the silver halide here forms a precipitate. It's very important at the beginning of this test that we react it with dilute nitric acid to remove any other ions which might be present in the solution, which will interfere with the test. We also need to know the outcomes or the colours of the precipitates formed, and fluoride doesn't form any precipitate, a chloride will form a white precipitate, bromide will form a cream precipitate, and iodide will form a yellow precipitate. It's also useful for to be able to recall the ionic equation here, where we have the silver plus positive ion reacting with a negative halide ion to form a silver halide. It sometimes can be difficult to tell the difference between the white, cream and yellow precipitates formed. So to make this easier, we can dissolve the precipitates using ammonia. Chlorine dissolves easily in dilute ammonia. Bromine dissolves in concentrated ammonia, and iodide is insoluble even in concentrated ammonia. I hope you found that video on the halide ions useful. If you want to watch our video about the halogens, there should be a link on the screen now. And if you'd like to find out about videos for next week, make sure you subscribe. Thanks for watching.